This filament has a very strong unpleasant odor. Can this filtration system reduce it? I don't know, let's find out. Hello, welcome to my tech fun. Mintion company sent me their air filtration system for the testing. I got this box for free, but there is no additional payment from their side. But this video and actually the whole channel is sponsored by Polymaker and by my Patreon supporters. This system is engineered to capture harmful particles and fumes released during the 3D printing, which are very noticeable with some specific materials like ABS and similar. Triple layer filtration for maximum protection. Pre-filter traps larger dust particles. HEPA H13 filters capture ultrafine particles generated by printing with the PLA, PETG, ABS, nylon. Activated carbon bed absorbs VOCs and chemical fumes such as styrene and similar. According to the website, by default it's shipped with the connector for the P1S and X1 carbon bed bullet printers, but on their website we can find many other connectors for H2D, Prusa printers and similar. Only they don't mention which material we should use for 3D printing. If you plan to use this connector for some enclosed printer, especially with the actually heated chamber, then don't print this from the PLA, at least PETG or even some more higher temperature resistant material. I was in quite big dilemma how to test this, because I have an Air Gradient 1 air quality monitor, but it mainly measures PM1, that's 1 micrometer size. But 3D printer emissions are much smaller than this, between 0.01 and 0.1 micrometers. Additionally, VOCs are gases and not particles. So instead of just showing you some misleading numbers, I decided to have much more practical approach. I will print with some smelly ABS or ASM material, and if I will not feel that smell in the room, then this system works fine. And I know that this testing method should work, because my X1 carbon is connected to that ventilation hole on the wall, and usually when I print with ABS, ASA or some smelly material, I enable the exhaust fan to 10%, and this creates some negative pressure inside the printer because the sealing is never perfect. And with this, nothing escapes to the room, everything goes to that ventilation hole, and in this case I will use the saving method. Only that fume will be captured by the filter. If it works correctly, then I shouldn't feel any smell in the room. Yes, always get the comments why I don't mention the price. And in this case I can see only the European price in Hungarian forint, but if I convert it to the dollars, the price of this whole system with the filters is $76, and the price of the replacement filter is $25 for the whole set. And according to the website, for the general use PLA PETG with 8 hours per day printing, we should replace this filtration system every 3 months. Of course, with the VOC heavy usage, it's a little bit different, but all the information we can find on their website. The material I will use for this testing is Bambu Labs ASACF. The final product is good and strong, but this filament has very specific and strong smell during the printing. Now let's see what's in the box. Content of the package: user manual. This is that air filtration system with pre-installed filter. This pipe is approximately 1 meter long and the end is soft for better sealing. Then we have this sealing cover, some screws and tools for the assembling, and this is 24 volt DC power supply. And it is adjustable. Now it's turned off, but we can set lower values, for example for the ABS. In this case it will create some negative pressure inside. Higher airflow values for PLA, for example. It will even cool down a little bit the air, and when we finish the printing, just set to the maximum and the air will be exchanged completely. And I think this is a good solution because some printers don't have exhaust fan like P2S. There it only sucks the air, but air goes out on different gaps, but with this we can control exactly where will that air go out. I just want to take a look at that filter. We have 2 red buttons on 2 sides. 1, 2. Oops. And 3. Okay, I will have a problem when I want to take it out next time. But that's the problem of the future, Igor, not mine. Before the installation, I have to remove my system. This is the back side of the Exxon Carbon, and this connector is printed from the PETG, and this red here is a TPO85A for better sealing. And I'm not using the AMS with my Exxon Carbon, so I don't have big amount of the poop here. This is attached with the magnets, and when I start with the printing, I just lift this up and it will cover this hole, because this opening is completely open, there is no sealing, and those fumes will go out here too. In this case we have 3D printed cover which should be installed here, but I will just use my method using this sealing method. I don't really remember if these holes are there here. I think they were here, only I cut the M3 thread in them. I try to reuse my bolts, I hope they are long enough. This arrived in a package and it writes M3 by 10, but to Mintion a reminder, this is not M3 thread. Maybe they are 3 mm in diameter, but not M3. This is some kind of self-cutting thread. It is assembled, I could reuse my old bolts and the holes are in the correct place, and I will use this for the sealing covering of this opening. Let's see how loud is this. Now it is on a minimal ASA ABS strength, PLA, and at the end of the printing I should set it on the maximum. I don't think it will be louder than the printer itself. Now let's print something. I already mentioned it will be Bambolab ASA CF, and I cannot use the spool holder because in that case I cannot cover this opening. I designed this a few years ago. Currently I don't need anything from the ASA, but I'm using these hooks a lot, and I can have one for the outdoors too. This is the preview in the slicer, different settings for this filament, and printing time will be approximately 2.5 hours, should be enough for the testing. Flow strength set to ABS ASA printing. But even here I like to set the chamber fan to 10%. It started with the printing, so I'm covering this opening. As expected, I couldn't record any significant changes with this air quality monitor. Here you can see the graph for the moment. After approximately 1 hour of printing, extremely minimally, but I can feel that smell of the ASA, but interesting, not from here where the air comes out, here you can see on this paper, but it comes out somewhere around the printer, so the sealing is not really perfect, but this is not the fault of the air filtration system. Let me ask my family members. So in the meantime I asked my 2 oldest daughters, only they are here, and first when they came into this living room they couldn't feel any smell. Only when they came around the printer and on the back side here they could feel the smell, and I noticed here on the opening for the poop chute the smell comes out a little bit, very minimally, so definitely it needs a little bit better sealing than this magnetic cover. I know maybe I should use originally provided sealing for that covering, but this is not the perfect neither. But anyway, this smell is so weak that it doesn't bother me and I can work next to it. Only disadvantage I notice of this system currently is that the temperature of the enclosure peak on 43 degrees Celsius, which is enough for the carbon fiber reinforced ASA. But of course I can always reduce this fan and have higher temperatures here. I just came home from the school. Printing is finished 10 minutes ago and yes, now I can feel the smell. It was too early to open it. Now let's see after additional 5 minutes. Yes, definitely much better now. And now I have this hook for outdoor use too. For my needs, this works really nice. Of course I will stay with that ventilation hole on the wall, there is no better solution than that, but actually in my workplace I don't have any solution for the ventilation, and from the same reason I don't have a printer for the ASA or ABS there. And this looks like a nice solution for this. And I'm curious, what is your solution for the ventilation? So if you are printing ABS and ASA, I'm curious what kind of ventilation are you using. Thank you for watching this video until the end, and happy printing!